So, today we are going to continue our study of gravity. But before you guys move on to learn about how gravity affects the orbits of our planets, what I need to make sure is clear up the difference between mass and weight. So, when we talk about mass, it's the amount of matter in an object. So, when I think about mass, I'm thinking about the types of atoms are within an object, how much is packed in there, the types of elements that are in something. And I always think back to those blocks that we did, those cubes when we were studying density. And we picked up something that was steel, and steel has iron in it. And when we are talking about its mass, it was how much iron atoms are packed in there. But then we turned around and we weighed the object. Now, on Earth, we did use weight and mass pretty interchangeably because we would say that the block weighed a certain amount. But truly, weight is the effect of gravity on an object. So, mass is the amount of matter, weight is how gravity affects it. Now, some of you were saying how matter or mass is how much space something takes up. Well, that's not true. Space, how much space it takes up, that's volume. Don't worry, we are not going to do any formulas, talk about volume, but I wanted to make sure that its mass is not how much space it is. However, a lot of times, yes, the more mass it has, a lot of times it is bigger, but that's not always the case. So let's go back to our mass and weight. Now, this is probably the clearest way to describe how they are different. So when you were doing the activity in the Nearpod on Tuesday, you guys got to put your weight in and tried to see, well, what would you weigh if you were on different planets? And then you had to draw that. So here's two examples. So for the first one, we can see that somebody was 80 pounds on Earth, but then when they went to Jupiter, they were 202 pounds. So their weight definitely got more on Jupiter. Here's another one that said 110 pounds on Earth and then 278 on Jupiter. And what happened here is there's less gravity here. So if there's less gravity, you're going to weigh less. These people were almost there. They're showing that the person is smaller here on Earth to indicate they were representing that you would weigh less, and then got much bigger on Jupiter. Same thing here, way less, way more on Jupiter. But one thing I wanted to clear up, and I know you understand it, but this might clear up mass. Your weight might change if you were to go to Jupiter. However, your mass does not get bigger. You don't all of a sudden become a 303-pound person. Your mass stays the same. Your mass, which is the matter inside you, so the amount, the blood cells and your muscle cells and your bone cells and the fat cells, and that all stays the same. The matter stays the same, but the pull of gravity is a lot more, which makes you have a much feel heavier, feel the weight is going to be there. That's why when you see pictures of astronauts or videos of astronauts when they're on the moon, it's almost like they are just bounding because there's less gravity holding them down. So they feel lighter. I saw this picture and I'm not really sure what that means, but let's move on to the final ones. This is exactly right. As you can see on this one, the person's mass is the same. They're the same exact size. However, Jupiter is bigger, has more gravity, so therefore that person weighs more. Okay, and here's a nice summary. Earth is smaller planet than Jupiter, so its gravitational pull doesn't pull as hard as Jupiter does. So, what's the takeaway? What did I want you to get from this? The main thing out of the first 2 days that we did is that the larger the mass, so the bigger the planet like Jupiter, the more gravity it has. That means it's pulling more on the object. This is really important to understand because as we go forward, we're going to start learning about the formation of the solar system, and gravity has a huge role on that. When stars are created, gravity, how the planets stay in their orbit has to do with gravity and, of course, the tides. So today, when you are studying gravity, you're going to take a look at the orbits. So you will be there's a worksheet that you are going to click on. And when you go to the website, you're going to click on this model here.